Whoa. So these identities, you do not have to memorize them. I will give them to you, okay? And these are double angles. So for example, let's say you needed an angle and it wasn't on the unit circle. Well, if it was double of whatever is on the unit circle, you could use one of these handy dandy identities to help you out, okay? And they're pretty straightforward. So the sine of 2u, whatever 2u is going to be equal to 2 times the sine of u times the cosine of u, all right? And then the cosine of 2u has multiple ones that it can equal. So if you're working with a cosine, you can pick any one of the 3, and some of them are going to be easier than others. And then the tangent, this would be the identity for the tangent of 2u, all right? So let's just go ahead and see them in action. I think you'll be like, oh, this isn't too bad. All right, so the tangent of theta is negative 4/3, where theta is between 270 and 360. So let's talk about what's going on there. Where is this angle at? What quadrant? This is in Q4, right? So if you draw yourself a triangle in Q4, it's going to be down here, and this would be your theta. And tangent is negative 4/3, and what is the tangent in terms of a triangle? Tangent in terms of a triangle? Opposite over adjacent, right? So the opposite is the negative 4 because it's going down. The adjacent is 3. By the way, what does that make the hypotenuse? 5, right? 5. All right, and we want to find the sine of 2 times that angle. So whatever that angle is, we want the sine of 2 times it. So here's what it is. It's equal to 2 times the sine of theta times the cosine of theta. That is the identity. So this would be 2 times the sine of theta. So using your triangle, what is the sine of theta? Yeah, negative 4/5. And then times the cosine of theta. Using your triangle, what's the cosine of theta? 3/5. And just multiply them all together, and you have the value for the sine of 2 theta. By the way, you can multiply the 2 times negative 4 times the 3 because those are all on the top, right? 2 times negative 4 is negative 8. Times 3 is negative 24. Yes. And then in the bottom, you'll have a 5 times 5, which is 25. So the value of the sine of 2 theta based off of this situation is just negative 24/25. What do you think? Super crazy? You're just following the identity, right? Following the identity. All right. The next one we have cosine of theta is 3/5, where theta is between 0 and 90. 0 and 90 would put it in what quadrant? Q1, yeah. Q1. And this says find the cosine of 2 theta. So you could draw a triangle here to represent this, right? But I'm going to tell you a little bit of a secret. If you're looking for the cosine of 2 theta and you have 3 to pick from and you already know the cosine, it just flat out tells you, would you be better off to pick the first one, the second one, or the third one? The second one, because it already has a cosine in it, right? So if you pick the second one, you don't have to draw the triangle because you don't need to know anything else. You just need to know the cosine.
Any third block EC3 student needs to be at the lobby at this time. Third block EC3 student.
So here's the formula. It's 2 times the cosine squared minus 1. And so it'll be 2 times the cosine, which is 3/5 squared minus 1. And so you can go ahead and evaluate that. 3/5, what's 3/5 squared? 3/5 squared. 9/25. And then that gets multiplied by 2. So 9 times 2 is 18. So that's 18/25 minus the 1. And 1 we should think of as what over what? 25/25. We're on page 5, Amelia. Page 5. And so 18 minus 25 is? Negative 7/25. So the value of the cosine of 2 theta, whatever that angle was, double the angle is negative 7/25. All right, how are we doing so far? Yes, no, maybe? Yeah? Doing all right? See what I mean by this wasn't too bad, right? Not too bad. All right. All right, so the next one we have the sine of theta is 15 over 17, where theta is between 90 and 180. So what quadrant is that in? That's Q2. And we want to find the value of the tangent of 2 theta. So using the tangent identity, we'll find that value. So we need tangents, right? And we have sine, so that means we will have to make a triangle, won't we? All right, so let's make that triangle. In Q2, it's going to look like this, right? Theta, Q2. Sine is what over what? Opposite over hypotenuse. And then to get tangent, you do need to know the adjacent, the third side, right? And you have options. You can Pythagorean theorem, or you can maybe think if it's a Pythagorean triple, that might be helpful too. Anybody know? It is 8, isn't it?
Yeah.
8, 15, 17 is a Pythagorean triple. So if you know your triples, it makes your life a lot easier here, right? All right, so the tangent of 2 theta, we're just going to use the formula. So it's 2 tangent, so 2 times the tangent. What is the tangent of that angle then, now that we have our triangle all right now? Tangent is 15 over 8, and technically, since we're in Q2, it is a negative 8, right? So 15 over 8, that is negative. And then all over 1 minus tangent squared. So 1 minus negative 15 over 8, the same tangent, but that is being squared. And this one, I'll let you use your handy dandy calculator. Yeah? Yeah, fractions and fractions being squared and added and subtracted, all that fun stuff. By the way, do you know how to put a fraction into your calculator? Yeah, you can do divide, or you can make it look a lot nicer and do alpha y equals. I would do alpha y equals. At least to get the big fraction, right? And then if you want to do these little fractions, the 15 over 8 as a division symbol, that's fine. But I would at least get the big fraction on there. That way you don't have to like calculate the top and then calculate the bottom. Yeah, you can add extra parentheses. That's fine too.
How did you get to alpha y?
You hit alpha,
Yeah.
and then y equals up at the top.
Oh.
There you go. And then the very first option is like n over d,
Yeah.
and hit enter. So that'll put in a fraction for you. Huh?
One of my math teachers taught me that a long time ago.
Ooh, a long, long time ago.
I think it's u n over d. Because n over d is numerator over denominator.
Yeah, those ones just get a little fancier. You can mess around with them later if you want, but.
That's a weird fraction.
And then you can hit math enter, right? If when it gives you the decimal, if it doesn't spit out a fraction. I end up with negative 240 over 161.
Oh, mixed number. Okay.
It's in Q2, so make sure that tangent is a negative number, right? Do you have positive or negative?
I got positive 240.
Mine's negative.
Yeah, let me check again real fast. I could have missed the negative as I was typing it in.
I know one of them gets squared out.
It does.
Over
8. 1 minus.
Well,
Oh, I do end up with the positive, so I must have
because
typed it in.
The negative on the bottom multiplies out or squares itself out and becomes positive, but then it subtracts.
But then this one subtract makes it negative still. Yeah.
And then it divides out.
What was that?
I thought the tangent was always negative.
This is a tangent of 2 theta, so you have to think about where 2 theta would end up. If theta is in Q2, if you times it by 2, it's not going to be in Q2 anymore. It's going to move, right? Yeah. Trust the signs of what you put in here, okay? All right. Let's try another one. So number 4, we have tangent of theta is negative 4 over 3, where theta is between 3 pi over 2 and 2 pi. What quadrant is that in? Q4. So that's Q4. Before you make the triangle and fill it all in, make sure you need it, right? So it says, find the tangent of 2 theta. To find tangent of 2 theta, you just need tangent. And we already know the value of tangent, don't we? So do I have to make the triangle? No, because I don't need to know the hypotenuse. I don't need to know sine. I don't need to know cosine. Just the tangent. So this will be 2 times -4/3 over 1 minus -4/3, that whole thing squared. So calculate away. Yeah, that's what I got too. Anybody else with the 24/7? Yes? Awesome. All right, let's check out the next one. So cosine of theta is -5/13. 5 pi over 2 to 3 pi. We're going to have to think about this because that's more than a 2 pi, isn't it? 3 pi would be the same as pi, right? So if this is the same as pi, this one comes before it, which would be pi over 2. So what quadrant are we in? Q2. Yeah, this is in Q2. And we have the cosine. It is negative, which, by the way, in Q2, cosine is negative, right? So that's kind of a nice little check. And we need to find the sine of 2 theta. So to find the sine, you're going to use the sine formula, which means we need both sine and cosine. So do we need to make a triangle? Yeah, make yourself a triangle so you can figure out the sine value. So cosine, -5/13. Cosine is what over what? The adjacent over the hypotenuse. So the -5 is your adjacent. What is your opposite then? Is it a nice number, or do we
12, I think.
have to Pythagorean theorem? 12? What do you think? 12? 5, 12, 13? Yeah, 5, 12, 13. And that 12 will be positive. So the sine of 2 theta is 2 times the sine of theta based off our triangle. So sine would be 12/13 times the cosine, which they already give it to us, or we could reference our triangle again, right? -5/13. And you can go ahead and multiply this out. If you want to use your calculator, multiply it out, that's fine. If you want to do it in your head, I would go 2 times -5 and say -10. -10 times 12 is -120. And 13 squared is 169. I did get a negative, yes. Over 169. Yep. That's it. So the bell came early. Tomorrow, we can finish that last one if you want to talk about it. And you don't have to start the homework tonight, all right? Is everybody cool with that? Don't have to start. So tomorrow we'll talk half angles, and then this shouldn't take us all block, so you can have the rest of class tomorrow to work on